Okay. Everybody loves rate problems. It is so true. So we probably remember the distance equals rate times time. Well, remember that you can solve this equation for any variable. The problems that we'll be doing today, we'd like time as as the isolated variable. So this is the same thing as time equals distance divided by rate. Okay? So, me. I can drive 200 miles in the same amount of time the bus can go 175 miles. Okay? I go 10 miles per hour faster than the bus. That's why I get there faster. That's why I can do more miles in the same amount of time. Reason for this is the bus has to stop a little bit more than I do. They have to follow up maybe a few more of the traffic laws than I do, so I get there a little faster. Okay. So let's put down my formula for my time. So my time is my distance divided by my rate. My distance is 200. And my rate, I don't know what it is, I'll just call it off. And the bus, their time is their distance, 175, divided by their rate. Their rate is not the same as mine. I go 10 miles an hour faster. So I'll call their rate my rate minus 10 miles per hour. Or you can add the 10 up to mine and base things on the bus's rate. Doesn't matter. Okay, our times are the same. So let me just set these two equations. I'm going to do a substitution. Wherever I see time in the bottom equation, I'm going to put 200 over r. So I get 200 over r equals 175 over r minus 10. Hopefully I have an equation here that you could have solved in Algebra 1. So that's 200r minus 2000 equals 175r. Subtract 200r from both sides. Negative 2000 is negative 25r. Divide both sides by negative 25. What's 2000 divided by negative 25? 80. That seems reasonable. My rate is 80 miles per hour. How about the bus? Yep, it's 10 less. Is that far enough? Okay. Okay. Now we're going to do a different kind of rate problem. And these are, instead of distance, I'm sorry, what? All I did was solve for the rate. If I needed to solve for the time, I could now figure out the time. So my rate is 80 miles per hour. I think your problem today only asks you to find rates, so I'm going to leave it there. Okay. So my next example, which will be your second two-word problems, is about the rate of a job. Particular kind of rate of a job. So instead of distance, I can use jobs. So instead of D equals R times T, I can use some job is equal to R times T. So I'm going to solve this one again for T. Does that seem right? Yeah. I want this to be time. I want it to be rate. Job. Okay. I can solve this one for T. So T equals J over R. And now here we go. I can finish my homework. In 2 hours. Zoe can finish the same homework, my 8-year-old daughter. In 5 hours. How long will it take us working together to finish this same assignment? Will it take to finish the homework? If we work together. Now, usually things take longer if you work together because you tend to talk a little bit more. But we'll just use our straight rates and say that we don't waste more time. We should put a little wasting time factor in there. Okay. For me. My rate is, I can do a job in 5 hours. And let's see. I'm just going to call that my job. I'm going to, instead of using J, I'm going to use X. And there is my time. X over 5. And for Zoe, her rate, oh, my rate is 2. I'm the fast one, sorry. Zoe has the rate of 5, and there is her time. And if you sum my rate and Zoe's rate, you're going to get us the amount of time, if I solve for X, to do one whole job, one whole assignment. That number will change if we needed to do 3 assignments or 10 assignments. Yes, sir?
Dividing by a smaller number, aren't you going to have to take more time?
We're doing this job one time. Well, it's the reason that I divide is because that that X is actually going to be a fraction of a job.